to do it. But let me start with what we're doing today. So we're doing more continuity. So last time, a few classes ago, we learned what limits are. And then last class, we learned this idea of a continuous function, which has something to do with limits, right? So continuous means it's a nice function, nice and smooth. Maybe smooth, I shouldn't say smooth. Smooth means something else. It's a nice function that you can draw without taking your pen off the page, and it has something to do with limits. That's what we're doing. We did this example, which I think is a really instructive example, where it was a piecewise function, and we decided what was the limit and whether or not it was continuous based on the algebra rules that were given. This is a very instructive example. Hint, hint. OK. Any questions or comments about this one or anything else? Midterm 2 coming up. Questions about midterm 2? Yeah? Yes, you are allowed a formula sheet. It's the exact same rules as midterm 1. It's all posted on midterm 2 info on course link, the exact rules, but they're a copy paste of the midterm 1 rules. Yeah. Yeah. Yes, it will be posted this weekend. So it is not posted yet, but it will be posted soon. Yes, there will be a practice one as well. OK, any other questions or comments? Midterm 2? OK, so today we're doing more of this idea of what are continuous functions. And we're starting with the same exercise as before, but part D of the exercise. So on page 405 here, is the function f of x equals square root of x continuous at x equals 0? Very innocent sounding question. Why would there be any issue with this question? Let me draw a graph of square root of x to tell you what the issue is. So here is my x-axis, here's my y-axis. Let me draw the graph of f of x equals square root of x. It is a function that looks like this. It goes bloop, 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 and like that. So the square root function, everybody knows the square root function. It ends at 0. Very nice function. What could possibly be the issue with this function? The issue is it is not defined for x less than 0. It is not defined for x less than 0. OK, who cares? Why is that an issue? The issue is at x equals 0, if you want to decide if it's continuous or not, you need to do the limit as x goes to 0 of square root of x, right? The limit will tell you the value of the limit. If it matches the value of the function, then it's continuous. So basically, we're answering the question, is this equal to 0? That's if the answer is yes, then it's continuous. If the answer is no, it's not continuous. And why 0? Because 0 is the square root of 0, is the value f of 0. So if the value of the function equals the value of the limit, yes, it's continuous. That's what it means. If not, no, it's not continuous. Why is this an issue? Well, to do the limit as x goes to 0, you actually have to do two limits, right? This is the pattern that has been here this whole time, is the limit from the left and the limit from the right, the limit from the left, and the limit from the right. OK? Limit x goes to 0 minus and limit x goes to 0 plus. And one of them involves numbers that are less than 0. This limit x goes to 0 minus, is talking about the x values going in towards 0, but they're a little bit less than 0. So negative 0.1, negative 0.001, negative 0.001, negative values that are approaching x equals 0. And of course, this is total bananas nonsense because the square root of x does not exist here. Square root of x does not exist here. So that's an issue. This limit, we can't make sense of it. The function just does not exist. That is why it is hard to make sense of this limit. That's the idea. That's what we're going to start today. Any questions or comments about this idea? I'm trying to explain why there's a problem with the function square root of x. In a minute, we're going to solve the problem. But if you don't understand why there's a problem at all, then it won't make sense. Questions or comments? OK, everybody's getting the stupid function is not defined. So now you have two choices as a human. You can decide what to do in this situation. This is a situation where things are broken. And you have two choices. Let me start with option 2. Option 2 is like the absolutist position. Option 2, this is like the no exceptions, like we don't make exceptions for anybody. We say option 2, the function doesn't exist. This limit straight up doesn't exist. Limit does not exist. Limit does not exist. Therefore, straight to jail. Not continuous, right? Not continuous. So you say like, look, this thing in red, the function doesn't exist. I can't do the limit. Doesn't exist. No good. And so the answer to the question is the limit as x goes to 0 of square root of x, you would say that doesn't exist because x goes to 0 minus doesn't exist. So this is like the absolutist position. I can't define the function when it's less than 0. The whole thing doesn't exist, no exceptions. All right, that's the absolutist position. Option 1, in contrast to that, option 1 is the kind of like, let's try to work it out thing. Option 1. You're saying, well, OK, like you were thinking about the function square root of x. We know square root of x is not defined for negative numbers. So probably you just don't care about negative numbers. So it's OK in this situation, when we're talking about the function square root of x, to ignore the negative numbers, because we don't care about negative numbers. It's the function square root of x. So that would be option 1. You say, make an exception and only look at where the function is defined. So you say, let's only count where square root of x is defined. So in other words, because square root of x is not defined for the negative numbers, let's just ignore the negative numbers. And then the answer to the question would be yes, because the limit exists as long as you come in from this side where the thing is fine. And another point in favor of option 1 is that the idea of can you draw it without taking your pen off the page is perfectly fine. You can definitely draw this function without taking your pen off the page. So that is the option 1, and you would come to the conclusion, it is continuous. So you'd say yes, continuous, if you're an option 1 person. Yes, continuous. So if you're option 1, you say, is it continuous? Yes. And if you're option 2, you say no, not continuous. I'm doing CON''T for shorthand for continuous. Which is right? So a lot of times in this course, we've been discussing, is it right or wrong? This is not one of those situations. In this situation, option 1 and 2 are both equally valid. They're just different ways to interpret what it means to be continuous for a function that's not defined everywhere. So some mathematicians will say option 1 is the right one. Some other people will say option 2 is the right one. And both of them, if they're nice people, will recognize that the other side is just a difference of the definition. Okay? So the real answer to this question is f of x equals square root of x continuous at x equals 0. The only absolutely correct thing you can say about this question is this is an ambiguous question. It is ambiguous. Ambiguous. Why is it ambiguous? Because you haven't told me, are we talking about option 1 or option 2? So actually what we're going to do is we're going to learn how to make this sentence less ambiguous. We're going to add words to is it continuous to specify what exactly are we talking about so we don't have any ambiguity left over. That's the big idea for today. Any questions or comments about this one? So just for fun, again, there's no wrong answer. In Math1030, I made it so you guys could pick which you think is better. So this whole spiel on Math1030 is exactly what I just said. Is the function square root of x continuous? The question is ambiguous because the function is not defined. And there are 2 reasonable ways you could resolve the ambiguity. So if something is ambiguous means it's not perfectly defined. You have to make a choice. And you can choose to be an option 1 person and say it is continuous because the limit works wherever it is defined. Or you can say option 2, it's not continuous because the limit for the negative numbers does not exist. And it's up to you. Neither is wrong. It's just a matter of opinion. So it's whatever you like better. There is no wrong answer for this one. Let's see what people said. People like option 1 better. That means you guys are a friendly, accepting bunch, right? Like you're OK with the function not being defined. And of course, what is the right answer? They're all correct. Both of them are correct because, like I said, it's just a difference of opinion. So ultimately, what are we doing today? We're trying to come up with non-ambiguous versions of this statement. As written, it's ambiguous. Let's make it non-ambiguous. And how are we going to make it non-ambiguous? We're going to add some words to it. So we're going to make a better question. That was a bad question because it was ambiguous. How do we make it better? We say, is f of x equals square root of x continuous at x equals 0? That's exactly what is written already. But we're going to add some extra quantifiers, extra help to make it non-ambiguous. And we're going to specify from the right. From the right. Or you could specify, exact same sentence. I'm going to use these little quotation marks to mean copy everything out. And you could say from the left. And by saying from the right and from the left, it specifies what exactly you mean. And there will absolutely, even though the original question had was ambiguous, there was more than one answer. Now if you say from the right and from the left, there will only be one answer. From the right will be yes, absolutely yes, no ambiguity anymore. It is continuous from the right. Is it continuous from the left? The answer will be absolutely no, no. So, and I'll tell you exactly what they mean in a second, but it's a kind of like the geometric intuition of left and right will carry us through. So from the left and from the right is going to resolve the ambiguity. Later in the lecture, after we do from the left and from the right, we're going to also see another way you could specify the ambiguity by specifying which x values you care about. And like ultimately, option 1 and option 2 is which x values you care about. Do you only care about positive x values? Then you're an option 1 person. Or do you care about negative values too? Then you're an option 2 person. So another way to specify it is you could say, is the whole thing continuous, f of x equals square root of x, continuous at x equals 0 on the real number line, on the real number line. And the real number line includes both positive and negative numbers. And if you're including negative numbers, then the answer is going to be absolutely not. So the difference between including on R and what is written there is on R deliberately specifies all the negative numbers as well. And if you want to include the negative numbers, then there's no way this limit exists because, look, it's just not defined on the negative numbers. On the other hand, if you want to say, look, I only care about positive numbers, there's a way you can say that. You can write the same sentence again, and you can say on x bigger than 0, or you could say, or x is in 0 to infinity. Those would be two totally valid ways to say I only care about positive numbers. And if you write that, the answer will be yes. Because if you only care about positive numbers, that's option 1. OK. So we're going to take this ambiguous thing. We're going to learn how to make it more precise so there's no ambiguity. And that's going to help us describe the functions that we care about, like sine of x and square root of x. We're going to say where they're continuous or not. So that's the plan for today. Any questions or comments about that whole idea? OK, let's move to an example. And by move to an example, I think first we're going to do the definition of left and right. So left and right is over here. So continuous from the right, before we say what continuous from the right is, let me remind you, what does continuous mean? Continuous at x equals c. That means the limit as x goes to c of f of x equals f of c. So continuous meant look at the two-sided limit, the limit as x goes to c. Continuous from the right means only look at x goes to c plus. We only care about the right limit. So the limit coming in from the right side and going down. Continuous from the left means I only care about the limit from the left. And already this is, if you have this from the left, from the right thing, we can go back and see the example we just did. It's written down here, example 11. In the last example, the limit as x goes to 0 plus of f of x equals f of 0, right? That is the picture that I drew before. Let me draw it again over here. So the limit from the right is this one coming down like this. It approaches f of 0, which is 0. So it's definitely continuous from the right. The function square root of x is continuous from the right. And by saying from the right, you are excluding all the stuff happening on the left. That's why it fixes the problem. So even though the left-hand limit doesn't exist, that doesn't matter for the limit from the right. And that is why I said earlier that this is a perfectly valid way to fix it. Is it continuous from the right? Yes. That will be a yes, because the one-sided limit exists and is totally fine, even though the left limit doesn't make sense. So that's from the left and from the right. That's the definition. And you've had one example of it so far. I guess I could have gone into more detail about why the limit from the right equals 0, but hopefully this picture satisfies you. It's coming down. You approach 0. That's why the limit is 0. OK, yeah. Yeah, the stuff on the previous page, for sure. Oh, zoom out. Scroll up. The blue. OK, yes. We can take a picture of the blue. Yeah, no, of course, I'm always happy to do that. That's why we have two screens, so we can have one wherever you want it. OK. Any other questions or comments about this idea? So in a second, I'm going to set you loose, and you're going to do one. So if you don't understand, you should ask now. OK. Let's have you guys do one. We're going to skip this for now. We're going to this example. So here is a function. That's what it looks like. You got to tell me what is the limit, and yes or no, is it continuous from the right? Yes or no, is it continuous from the left? Okay? And I'm going to open it up in Math1030, and you guys will try it out. So here it is. Here's the same function, and here are the questions. The limit is a number you fill in, and I want you to say continuous, yes or no, from the right and from the left at 1 and 3, which are the two endpoints of this interval that we're looking at. Okay. Let's give you 2 minutes to try this one out. Let me know if you need more time. Who thinks they need more time? Anybody for more time? Okay. So last few people can put in their answers, and then we'll take it up. Okay. Okay. Let's take a look. The limit as x goes to 1 plus is what? So that's some number, and you had to fill in the number. Let's see, what did people think the limit as x goes to 1 plus is? 20 people said it's 1. One person said it's 1.6. The person who said it's 1.6 probably mixed up their 1s and 3s. So we're talking about this one side. It is 1. 1 is right. 1 is perfectly good. So great job, guys. I think that's the highest average we've gotten. 20 out of 21 people got it right. Very well done. Harder question, and this is the new topic for today, is it continuous from the right or not continuous from the right? 17 people said continuous, 4 people said not continuous. It is continuous from the right. Let me explain why with some equations, but I think you have the right idea. So the limit is equal to 1. Why is the limit 1? The x values get close to 1. The y values also get close to 1. So the limit is getting close to y equals 1. We're approaching y equals 1. So the limit is 1. And as it happens, nice coincidence for us, the value of the function is also 1. So the value of the function is this pink circled dot. This is the value f of 1. So f of 1, as it happens, is equal to 1. And now is the thing that is testing for continuous. Is the value of the function equal to the value of the limit? The answer in this case is yes. Yes, they're equal. 1 equals 1. The value of the limit is 1. The value of the function is 1. That means it's continuous. And the part with from the right just meant we were only looking at this one-sided limit. So again, extremely well done here. Almost everybody got it right. Great job. Let's see the other one. In the class at 2:30, most people got the first one right, and then less people got the second one right. Let's see. The limit as x goes to 3 minus. OK, this time we're more split. So 3 people are in 3. 1 person is in does not exist. 9 people are at 2.5, and 8 people are at 1.6. So very nice split here. Out of 21 people, it's basically 50-50 between 1.6 and 2.5. Let me give you guys some hints. The people who picked 3 are mixing up the x and the y values. If you pick 3, you're mixing up the x's and the y's. I want the x values to get close to 3. The x values are definitely getting close to 3. But we're asking you a question about the y values. So if you selected 3 That is what the x values are doing. I want to know what the y values are doing. And of course, everybody is noticing that 2.5 and 1.6 are the important numbers in this question. So this is y equals 2.5 is up here. That is definitely important for this problem. Y equals 1.6, that also looks important. And it could even be does not exist, right? Because sometimes when there's more than one y value, that means it just does not exist. So these are basically the 3 reasonable answers that you could come up with. Based on just the picture, 2.5 is important, 1.6 is important. The fact that we have 2 different things indicates there's some kind of badness, something to do with does not exist. So it's definitely one of these 3 options. So very good that you guys are onto that. Which one is it? Feel free to talk to your neighbors. I'm going to give you a revote. You can have another chance at it. Adrian and I are here. We're happy to help you out. Put up your hand and we'll come talk to you. We're going to revote it and we're going to see, is it 1.6 or 2.5? And again, this is a really fundamental concept for what is going on with limits, is can you do these limits from a picture? Really important concept for the midterm. So try really hard to get this one. And I know you guys can do it. So let me revote it and then we will take it up from there. Repeat and revote. OK. So there you go. It's open. I'll give about 2 minutes. I won't start a timer in case somebody wants to talk to me. Yeah, well, about 2 minutes. Or I guess until we get to like 20 votes. Then I'll stop at 20 votes. This question, the limit, is that the same as the question of is it continuous? Okay. No, it's good. Yeah, it's talking about. Okay, I'm at 19 people. 20. Okay, we just got to 20. Let's call it a day, and let's see what you said. So not a lot of talking. Maybe people are confident in their answers. Probably maybe nothing changed. Okay. All right, now everybody got this one right. Congratulations. Well done. Really well done. 100% on this. That's great. Okay. This one, oh no. 10 to 11, 10 to 11, 2.5 and 1.6. Congrats to the guy who was on does not exist, or the person who was on does not exist. It's true. It is either 2.5 or 1.6. I will tell you that. So it is either 2.5 or 1.6. So everybody picked one of the right 2 answers, but we're still like a 50-50 split between 2.5 and 1.6. So let's get some discussion. Does somebody brave want to tell us why they picked either answer, what they think makes that the answer? And it's OK to be wrong. In fact, being wrong is sometimes better than being right. Yeah. OK. Mm-hmm. Ah. OK, so let me take what you said. So you're saying you chose 1.6, and you said the reason you chose it is because it is connected. It's connected to the line. To the line. What a great sentence. Because it's connected to the line. You're saying the line is right here. We're connected to the line. Can I push you a little bit farther? Why is being connected to the line, what does that have to do with the limit? Because it's actually perfectly correct. Somehow connected to the line is the right thing. And so far, I have described limits in terms of getting close to. But what does that have to do with the line? OK. Yeah. Yes. OK, yeah. So this is the connection. The line is actually the y value of all the nearby points, right? That's what it means. When someone draws a line like this, what are they saying? They're telling you the values of f at all those points, right? They're saying f of 2.9 equals whatever this height is, 1.5 or whatever. So when someone draws a line, they're actually telling you the y values at nearby points, near to x equals 3. So the line is actually the nearby points, And the nearby points, exactly as was said over there, that is the idea of a limit. Limits are the idea of getting very, very close to, right? And so that goes, nearby points, that goes with the idea of a limit as very close to. Yes, great, absolutely great discussion. Does anybody want to say why they picked 2.5? Here, I'll say why you should pick 2.5. It's very obvious why you should pick 2.5, because that's where the dot is. Dot is at 2.5. Right? That's the reason you would think 2.5 is the right answer. Perhaps it has been sort of spoiled by this discussion. The correct answer is 1.6. The correct answer is 1.6. 1.6 here. So slightly over half the people got it right. What is wrong with the dot is at 2.5? It's totally true the dot is at 2.5, but that is answering a different question than the limit. The dot is at 2.5 tells us this means, let me write means. The dot is at 2.5 means, what does it mean? It means that f of 3 equals 2.5. So the dot being at 2.5 tells us definitely a useful piece of information. It tells you the value at exactly x equals 3. So when x equals 3, y equals 2.5. This is x equals 3, y equals 2.5. So if you pick that one, it's not that you're completely wrong, it's that you had the right answer to the wrong question. If the question said, what is f of 3, then the answer is 2.5. If the question says, what is the limit, then we're talking about this stuff, getting very close to stuff like that. And so the reason the answer is 1.6 is because when these x values, when they get really close to x equals 3, so here's 2.8, 2.9, then the y values are all on that little piece of the line right there, and they are getting closer and closer. They're moving up to y equals 1.6. So the limit is 1.6. The other half of the discussion is something that we already talked about, which is what is the value of f of 3? And that was 2.5. So that's this value over here, the dot being at 2.5. So the limit is 1.6, but the value of the function is 2.5. And this is like really an important thing to get clear in your head is what is the difference between the value of the limit and the value of the function? How are they defined? What do they mean? And again, it's hard, it's confusing because in a lot of situations they are the same, right? Everybody got question 1 right because they happen to be the same thing. So even if you were confused, you would get the right answer in question 1. In question 2, they're different, so you really got to clear it up in your head. Can I answer any questions or comments to help clarify it in your brain? Is there like something you're wondering? You're like, if I'm understanding it correctly, then blank. Tell me what blank is, I'll tell you if you're right. Okay, so hopefully this helps you understand. We've done a few examples like this already. There are some extra ones posted. There's a bajillion YouTube videos out there with these limits from the left and the right. Hopefully this helps you understand. It's a core concept for what we're doing with the stuff with limits. So I hope you will understand it before you go to the midterm. Okay, so the limit is 1.6. The value of the function is 2.5. The last question was, is it continuous or not? And the answer is not continuous, which most people got. So you can just see from the picture, it looks like a not continuous function. It looks like you cannot draw it without taking your pen off the page, and that intuition is correct. Mathematically, or like with an equation, how would you express that it's not continuous? You would say, look, this number 1.6 and this number 2.5, they are not equal. So as soon as they're not equal, that means that it is not continuous from the left. So continuous from the left is just saying that those two things are equal. We just figured out that they were not equal. Therefore, it's not continuous from the left. So is it continuous from the right? Yes. Yes. Is it continuous from the left? No. And I had a really good question last class, which is, shouldn't the left and the right be backwards? Because this whole discussion over here was on the right side of the interval, and this whole discussion over here was on the left side of the interval. So how come the rights and the lefts are backwards? The thing to remember is it's the direction. It's from the left or from the right. So this stuff is coming in from the left. This stuff is coming in from the right. So don't forget the word from that tells you which way the train is going. Okay. This is a good place to stop. This is all the good things. Please ask me questions about this stuff. Of course, there's more. I'm just saying the more stuff is going to build on this. So if you have a question, ask me now before it gets worse. Yeah? You mean the limit at 3? Yeah. So say your question one more time. Yeah. Yeah. Okay. So I think I understand your question. So in Math1030, we were talking about the limit as x goes to 3 minus. Maybe this is the detail that was important. We're talking about the limit as x goes to 3 minus. So it's true if in Math1030 it said, please do the limit as x goes to 3 with no minus sign, that would be an ambiguous question in the same way the very first thing we did was an ambiguous question. So the minus sign is carrying a lot of weight. The minus sign in Math1030, which is in super tiny font, so I don't blame you if you missed it. The minus sign is saying, please only look at the limit when we're coming in from one side. We're coming in from the left. And that is why in everything I did, I was only ever looking at this kind of thing, right, going up this way. I never looked from the other side because in the question, we're only ever doing the 3 minus. So this minus is important. I'm not sure if that was exactly answering your question, but does that help? Yes. OK, good. Yeah, this is if the question said, please do the limit as x goes to 3 of f of x, this is an ambiguous question. Ambiguous. For the same reason that the square root of x question that we started the class with was ambiguous. And that is because the function is not defined for x bigger than 3. So I don't know if you mean only look at values where f is defined, or do you mean look at all the x values close to 3, and so then you get this option 1, option 2 situation. That's why in Math1030 I said 3 minus. OK, yeah, great question. OK. Anybody else? OK, so the next thing in the notes, we have continuous from the left, we have continuous from the right. And if you know the concept of continuous from the left and continuous from the right, and you can answer questions like we just did, there is a simple way to explain to people where this function is continuous, right? So we just worked on this function. We know it's continuous from the left at 1. We know it's continuous from the right at 3. Oh, sorry, it's not continuous from the... I have things backwards. OK, we know it's continuous from the right at 1. And we know it's not continuous from the left at 3. This is a long mouthful of a sentence to say. So we're going to develop a shorthand. All of this stuff, all this information we had, we can condense it down to a simple sentence. We say f is continuous on 1 to 3, including 1 but not 3. And f is continuous on 1 to 3, including 1 with a square bracket, and excluding 3 means exactly what we just did. It means it is continuous from the right at 1. It is not continuous from the left at 3. All of that information is packed up into one convenient sentence. And by including or excluding the brackets, we can specify exactly what happens at the endpoints. The only thing that we didn't talk about is this definition also says that it's continuous in the normal sense and in the middle, say at 2, right? And you can just see from the picture it is continuous in the middle at 2. Those points are not in question. So this continuous from 1 to 3, closed at 1, including 1, but excluding 3, is a shorthand for everything we just did. In the notes on the previous page, they have these precise definitions. So if you want to read the actual definition, this is it. What does it mean to be continuous on closed at A, open at B? It means that you are continuous from the right at x equals A on that left endpoint, but you are not necessarily continuous at x equals B. So saying it's continuous from A to B is a shorthand way of saying it's continuous at the right, but not continuous on the other side. OK. You can have the same by symmetry. You have a to b the other way, right? Continuous at b, but not at a. And you can have continuous at a and b if it's continuous at both sides. So the actual question that was being asked in this thing, which I kind of ignored, is the actual question they wanted to ask was, is it continuous from 1 to 3, including both 1 and 3? And the answer to that question is no. Yeah, no, because it's only continuous on 1, 2, 3, without not including 3. So the question says, is it continuous at both ends? And we said, no, it's only continuous at one end. That's what these sentences mean. So it's a new notation for the same idea again. New words that mean the same thing. Any questions or comments about that one? Yeah. Yes? Yeah. So f is continuous from the left at x equals 3. The answer is no. That's this side. And again, don't get mixed up. It looks, you might think that this whole thing is, why is it from the left? It's on the right side of the page. But it's from the left because we're approaching from the left, even though it's on the right side of the page. So I might have, in talking, mixed up my lefts and rights. Hopefully it's clear. So yeah, it's a little confusing. From the left means on the right side. Yeah. Yes, right. Continuous means the value equals what it approaches. Yes. Yeah, this is a good observation. If it has an open dot and then a solid dot somewhere else, then it's not continuous because the value is not what it approaches. Yeah. Yes, very good. Yeah. Anyone else? Okay. So thus the answer is, I already said the answer. I said the answer is no. I guess this should have gone in this thing over here, but I like to make a war zone out of math. Okay. So here is another example. And this example, the last example was with a picture. This example is with algebra. So honestly, it's the exact same problem as before, but instead of giving you the information with algebra, instead of giving it to you with a picture, they gave it to you with algebra. Okay, so let's take a stab at solving it. And the question they said is it continuous on 2 to infinity, including 2, including 2, including 2. So including x equals 2. That's the question. Is it continuous on all the numbers, including 2? And the hint says, there's a nice hint, you may assume y equals x squared is continuous everywhere. Why is this a hint? Because our function has y equals x squared when x is bigger than 2. So the hint is actually telling us something nice. The hint says, by the hint, f of x is continuous automatically wherever it is equal to x squared, right? Because f is equal to x squared and x squared is continuous somewhere, so f is also continuous there. It's continuous on 2 to infinity, and this is not including 2. So by the hint, we have covered all the numbers except x equals 2. To answer the original question, is it continuous everywhere, including 2, we have just one piece of thing left to do, which is x equals 2 itself. So the only thing that remains, it only remains to check if it's continuous at x equals 2. Hopefully that logic makes sense. The question says everything up to bigger than 2 and including 2. By the hint, we've already done everything bigger than 2, so what's left over? Just x equals 2. Yeah? I said CON''T, which is short for continuous. Yes. Yes. Sorry. Yeah, I should have told you that. Okay. Not only is it x equals 2, is it continuous at x equals 2, actually it's a special type of continuous at x equals 2 because the interval on this thing, 2 is the left endpoint of the interval. So we don't need to check if it's continuous in the normal sense. We check if it's continuous from the right. From the right. That's all we have to do. And again, we don't have to check both sides because we're not saying continuous on an interval including 2. We're just saying 2 is the left endpoint. We only got to check from the right. So hopefully, let me know if there's any questions here. I'm going to prove that I'm going to check if it's continuous from the right. But so far, I've reduced the original question into just this question. Is it continuous from the right? Questions about how that worked? OK, so how do you check if something is continuous from the right? You have to compute two things. Compute and compare. I guess in English class they say compare and contrast. Compare and contrast. And contrast. What are we going to compare and contrast today in English class? We're going to compare and contrast the value of the limit x goes to 2 plus of f of x versus the value f of 2. That's what continuity means. We're comparing and contrasting the value of the limit with the value of the function. If they're equal, yes, continuous. If they're not equal, no, not continuous. So we got to do these two things. One of them is pretty easy, and that one is f of 2. F of 2. F of 2 is easy because, look, it's right there. If x equals 2, what is f? It's the value it says right here. Whatever it says here, that's the value. In this case, it's 2. So f of 2 equals 2. That's just by the thing they gave us. This one, how am I going to do this one? This one is more work for sure, but is still not so bad. And the reason is, this is a concept we've done before. When x is going to 2 plus, this means x is bigger than 2. X going to 2 plus means x bigger than 2. And x bigger than 2, I can also read off my function. So just like I read off the value 2 when x equals 2, I can read off that the function is equal to x squared when x is bigger than 2. So when x is bigger than 2, f of x is just x squared. And I'm still doing the limit. Let's keep that in blue then. That hasn't changed at all. So all I have used is that I know that the function is x squared if x is bigger than 2. So everywhere I see an f, I can replace it with x squared. So we've done this before. This is exactly the kind of limit that we did at the very end of last class, right? That was this limit that we had 3 votes on. It was exactly like this, right? Taking the value of the function and putting it into the limit where you know which branch to use where, right? So here is the red branch when x is less than 1. Here is the green branch when x is bigger than 1. Put the right formulas in the right places. OK, back to what we were doing. Back to what we're doing now. OK, so we just have to do this limit and then compare and contrast the values. How are we going to do the limit of x squared? That is one of these special just plug in functions. We can just plug in. Just plug in. You could say because x squared is continuous. Or if you're like me and you're lazy, you put C-O-N'(T) continuous. OK, so I just plug in x equals 2 because x squared is a continuous function, 2 squared. And what is 2 squared these days? It's 4. 4. OK. So I evaluated the limit. Any questions about how I did that one? So again, it's a repeat of before, but I think it is trickier with algebra than with the picture. With the picture, you can see this is algebra. OK, so one side is 4, the other side is 2. The answer to the question, is it continuous, is no. No. Is it continuous? Therefore, not continuous, not continuous, continuous. You can say because the limit as x goes to 2 plus of f of x is not equal to f of 2. One of them is 2, and the other one is 4. They are not equal. Therefore, it's not continuous. OK. That's that problem. Done. Any questions or comments? Yeah. Mm-hmm. Yeah.
Is it because you're trying to find that it's continuous at 2, like so the x equals 2 is approaching 2, but you're also inputting it into
Yeah.
this function? Would that ever not be the case? Would that ever be overused?
No, I think it would always. So once you have decided that we're just going to check x equals 2, then everything becomes about x equals 2. And on one side, you plug in exactly x equals 2. That's the stuff in blue over here in pink. This is x exactly equal to. And the other thing you got to do is the limit as x goes to 2. You have to compute those two things and compare them. And that tells you whether or not it's continuous at x equals 2. Yeah.
If we're doing a piecewise function,
yeah.
X equals something,
Yeah.
Uses that as like approaching final
Ah.
hypothesis x equals 2.
Yes.
So that means it must cross that to be continuous.
I think I understand what you're asking. This x equals 2 is exactly what happens at x equals 2. That is the same concept as the filled in dot before. So this value translated into what it's doing is telling you that there's a filled in dot when x equals 2 at y equals 2. At y equals 2. So it's telling you the value there. To figure out the limit, you have to look at the other parts of the function, right? Because the limit could be this other stuff that does like that, or maybe it does like this. So the value of the function will never tell you the limit. It will only tell you the value.
That's fine. I just didn't know if you could use that to find the limit.
Yes, so you cannot, that's what I'm telling you. This pink stuff doesn't tell you the limit. To figure out the limit, we had to use the red stuff. We used the red stuff to find the limit. This was the red stuff. So the pink stuff will only ever tell you the value of the dot. To figure out the value of the limit, you got to use the other parts of the function. And the analogy I'll give you is that in this previous problem we did, to figure out the value of the function, we used the dot. And to figure out the value of the limit, we used the other stuff. And it's exactly the same concept. So the dots tell you the value of the function, and the lines getting close to things tell you the value of the limit. In the algebra, the value at x equals 2 is the dot, tells you the value at x equals 2. And the other stuff is the line that tells you what happens nearby. Yes, there could be a part of the question just says find the limit. That could be a great question to put on a midterm. Yeah. OK. Yeah, in the back. Yeah, can I draw the graph? I can absolutely draw the graph because I know what the function x squared looks like. So the function, yeah, OK, let me do it in Desmos, because you know Desmos is like a better author, better drawer than me. OK, here's Desmos. OK, so we're looking at the function y equals x squared. That's the parabola y equals x squared. But we're only doing it when x is bigger than 2. So I put in x bigger than 2. It looks like that. That's the branch of the function that was in red, right? The red branch of the function. And I can do one of these to make it a little more parabola-y. OK, see, there's our parabola, OK? That is the branch of the function in red. I've done the red part. X squared if x is bigger than 2. I want to make sure to be crystal clear we're not including x equals 2, so let me draw a dot at 2, 4. That is not included, right? Because we said we're not including this stuff. So it looks like that, and I'm going to make it red. OK, there's our function. So that is the part of the function when x is bigger than 2, the red part of the function. Now let me do the pink part of the function, and that is 2, 2. 2, 2. And that is this point, 2, 2. We are including that. So I'm going to fill in the dots. It's filled in. And Desmos doesn't have pink. What's close to pink? Purple. Purple is close to pink. So I'm going to do it in purple instead. So this is what the function looks like. It has a red part of the function, that is x squared. The red part of the function approaches y equals 4. Right? You're coming down, down, down. You get to y equals 4. That is why the limit was 4. This limit was 4. Oh, look, I did it in purple. I knew. OK. The limit was 4. Oh, no, this is the wrong thing. OK, it's not supposed to be purple. So the limit is 4, but the value of the function is 2. And that is why it is not continuous. Those two things are not equal. So hopefully that helps you connect the two algebra and graphical examples. OK, this is this is a good discussion. I hope you guys will take this stuff seriously. If you didn't understand what we were doing, seriously, like, do not go to the midterm until you understand this. Like, you will get a lot of mileage out of it. Yeah? Yeah.
For the question, if it was saying like the bracketed,
Yeah.
if it's a big 2, it would be.
Yeah.
4, would you then try and find x as it approaches 4?
Yes. Yes. Yeah. Exactly. Yeah. OK. So really good class, guys. We're very, very close. We have like 10 more minutes of stuff on chapter 10, but everything on the midterm is up to and including what we did today. So make sure you understand that stuff, and make sure you take a look out for that practice midterm coming this weekend. OK, see you guys next week, and have a good, fun weekend.